All right. So happy Wednesday, everybody. Yesterday at the end of class, I logicked a little bit at least. We talked about this repetitive sort of behavior. If you didn't quite grasp what was happening, it's not the end of the world. I'm going to pretend like we didn't do that, and we're going to see the exact same answers. Now, as we go through, just remind me real quick and ask for a few of these things. And you might not have it from memory. You might have to look down. If I want to find the period of a function, how do we do it? You take 2 pi if it's sine or cosine, which is a regular period, and you divide it by b. Cool. How do you find the amplitude? It's 1/2 the vertical change, or if we look really closely, it's just a. When we look at a sine x, it's just that number. Okay. Other things that we identified. So the start, which is our phase shift, is where I start or end. And if we want to know where we start, we take the argument of our function, which is typically going to be of the form bx minus c, and we want to set it equal to what? 0. So you'll notice, and if I don't point it out, I think you will, every time that I solve this, b and c will change, but will my answer always be the same? Like, you say no, and I like maybe, but let's check. We did actually plug in the numbers yesterday, right? When we did ours. And I'm pretty sure if I go back over here, we're going to see, like, we plugged it in and solved it. Help me solve it first for x before we plug stuff in. Add c and then divide by. So I'm claiming maybe it's c over b. Was it c over b when we looked yesterday? C over b. Hey, it was exactly that value. And maybe, not maybe, terrible choice of words, it'll always be this value. But you can always just set it there. Last little thing that we would find is the jump on our table. How do you find that? You take the period that we found over 4. Now, the way that I typically think of this is, in my mind, because that can be misleading, because I say, here's the period, but you might be goofed up with the original period. The alternative is, if you don't want to just think the new period over 4, just take 2 pi over b times 1/4, and it's the exact same thing. That's still 1/4 of it. Now, with all that, if you can answer each of these questions, the rest of it, even with really ugly numbers, which these were intentionally ugly yesterday because we're doing this one together, it still works out the same. We've determined all of this stuff. We have our jumps and all this good information over here. If I want to get my next x value, and we're just going to jump in. We got 7, 6, and I just add pi 12ths to it, and we cleaned it up to make it this. How do I get to my next x value? You just add pi 12ths again. And when we do that, what's 14 plus pi over 12 plus pi over 12? So just in case, this is what I heard, and I agree with you. If anybody out there heard what I said and went, what? Because talking math can be hard, this is what it comes up to. 14 pi over 12 plus pi over 12, which hence the reason that I simplified it down like this. And I'm not going to simplify this one. That's just 14, plus pi, right? That's 14 plus 2 pi. Okay. Do you want to just figure it out here, or do you want to get all of our points first? All the x values? So add another pi 12ths to this. And what do you get? 3 pi 12ths. Yes, sir. You can. I'm not going. I would avoid it here. And the only reason I would is because if I give you this and say add pi 12ths, you can do it easily. What if I give you this? 7 plus pi over 6. And I said add pi 12ths to it. You have to convert it back to that anyway, so I might as well just keep it. Does that make sense? Okay. And I think one more, right? 14 plus 4 pi. Now, these numbers are awful, and we're going to sort it out. I have no idea what the decimals are, but we don't really need it. So let's check here. Now, knowing what cosine and sine look like from the get-go will help, because I know cosine looks like this, and just as relogicking, cosine does this, is what it looks like. That's its parent. And what I notice is we start, and then we go down a step, an amplitude, more specifically, and then we go down another amplitude, and then we go up an amplitude to get from here to here. We're going up. We go up one more. This is the pattern that it follows. Down, down, up, up, if it's just regular cosine. Does that seem, everybody okay with that language? So I'm using this, and you will use this, and I want you to use this, but let's verify that it works first. So here it's going to be ugly for a second, but this is 3 times the cosine of, and I'm going to use brackets so it's a little bit nicer, 6, and let's just make sure this mess cleans up nicely. 14 plus 2 pi over 12 minus 7. Okay, it's ugly for now. Is it going to stay ugly? My hope, and what I really hope happens, is this winds up pi. But let's verify that. 6 over 12, that changes to a what? So a 2 there, or a 1/2. I'll take either answer. I'm just simplifying in my work. Anybody opposed to that? So now I'll do a little bit more scratch work. I now have 3 times the cosine of, and let's just help me out here. 14 over 2 is plus, is it 2 pi? It's just pi, right? Why is it just pi? 2 pi over 2. Yeah, it's just pi. And then one more piece. What's 7 plus pi minus 7? And is cosine of pi a really nice value? What is the cosine of pi? I'm in the wrong spot again, aren't I? Is this pi for you? Gosh dang it. I did the same thing second hour. So there's pi, -1, and 3 times -1. Is that what I erased a minute ago? Now, here's where you get a choice. I need you to do one of 2 things for me. Your options when you're graphing these is I either need you to really lean in and be comfortable with this and use this to save yourself crazy amounts of time, option 1, or I need you to actually do the table. One of those 2. Which one do I recommend? For sure we want to use the shortcuts. We need the jumps. If we do everything correct here, though, all of these values every single time are going to give 0, pi halves, pi, 3 pi halves, and 2 pi. As long as we do it correctly, there's always a nice way through these problems. Just like with logs. If I wanted to know log base 2 of something, if I said, what's log base 2 of 3? Good luck. But log base 2 of 4 or 8 or any of those nice numbers work, and we pick values that work nicely. Mr. Baker, just hanging out? All right, I appreciate that. I agree. Awesome. Thank you. Cool. So check it out. I know that it has already gone down an amplitude. I see it here. It's gone down another amplitude. What's the graph do after we get down here? It goes up an amplitude and up an amplitude. What's the amplitude of this graph? I don't have it here. Oh, it's 3. It was 3 cosine, right? So if I know that it goes down, down, up, up, here I went down, down, go up 3 more. Where do we get? Go up 3 more. And now we have it. If you'd rather do all of this, I love it. You're allowed to do that. I'm not going to for like 99% of the time. It'll really be like 90% of the time because people will still have questions with it, and I get that. I would lean into the efficiency of these. Okay, let's actually graph this. And here's, I agree with Leilani's face. We're actually going to graph this, and I'm going to make a face real quick, and I want you to tell me, why am I making a face? Why don't I want to graph this? Oh my gosh, what is this? How do I find that number on the x-axis? Anybody have a good idea? I have a suggestion. There's 2 ways we can do this. One, I can do decimals. I could do decimals. Maybe, just maybe, we can pick our scale just right so we don't even have to think about the decimals. Now, what would you prefer? Would you just go to the decimals, realistically? Okay, I'll tell you with most trig stuff, I wouldn't, but I'm okay with it. All I need is 2 decimals right now. And for this, I'm going to show you what I mean by that. I don't know what 7/6 is. Actually, I do. It's 1.16, right? Is 1/6 the right number? 167. Somebody needs to confirm. No. I'm pretty sure it's 1.167. Can somebody second that? A sixth is 16 times 6 is 96, so it must be there. I'm pretty sure this is right. We're going to say it's right for now. Okay, every time that I do this, I add how much to it? Pi halves. Pi 12ths, which in my head, that's about a quarter. Real quickly, on your calculator, all I need you to do is add pi 12ths. 1 point. Am I wrong? Point what? I was trying to get her to say 6, 7 again. I'm actually looking at the wall right behind you. It just looks like I'm looking at you. What's the next number if I add pi 12s? I have no idea. 1.428. Okay, so check this out. If this is 1.1 and you said it's 1.4 or 1.1? 1.4. So do we all agree 1.4 is a little bit bigger than 1.1? So I'm eyeballing it. Here's my next tick. Did you notice the x value that I assigned it, or did I just go a tick over? This is pi 12s. Here's the second addition of pi 12s, and the third, and the fourth. And I can keep doing this by pi 12s over and over. I don't really care what the actual number is because I know that there's a really convenient pattern. I need to have this first number placed, whether I call it 7, 6 or not. Now, you guys committed to decimal, and I'll come back to it. But if I were doing this, I would have done this, and it's not going to be very different. I'd said here's 7 6, and then this is 7 6 plus pi 12ths. And I would have just said, look at this. This is the exact same scale, but now I don't have any decimals. Exact same scale. This is plus 12ths, plus 3 pi 12ths, plus 4 pi 12ths. As long as I have this first tick indicated, I'm just going to stay consistent with it. Okay. I'll go back to decimals, 1.167. And honestly, I don't know that I really care enough to put the other one, but you guys already told me what it was. What was this one? Do I need to put it? Okay. So now that I have these, how high up do I go? 3. And here's what's weird. No matter the amplitude, if we set our window, and when I say set the window, I mean we pick our scale, as long as we do a scale that's good, we're always going to get like the same picture, right? I can't tell the difference between cosine and this one if I'm graphing, because when I zoom in, I'm going to see that it's just one period. It's going to look like one period of cosine or one period of cosine, if you'd rather. We're zooming in. It's not going to be able to tell super clearly what the difference is, but I think we make it work. You tell me when to stop. When am I at 3? Why? Okay. If I want to stop here, can I? Okay. I was just curious where you guys would stop. Once I get this, and there might be some shortcuts through here that I encourage you guys to think about, but I'm going to claim to graph this function, all I really need is this point. At 7, 6, it's 3. Now, we did the whole table, right? Like we did the whole thing. Is the table terrible to make? Who was not quite comfortable with how I got these next numbers? Was it everybody really truly was comfortable with those? So I just want to show you something. The efficiency thing is always a big part of what I try to push here. Let's pretend that I let us stop here yesterday. If I still think about what I know cosine does, and I know the amplitude, do I really need the rest of this table to construct this graph? I know that every step along the way, it's amplitude. So I don't even remember what the numbers were right now, but I know that it matters. I know that cosine starts up and then it goes downward in amplitude. It goes downward another amplitude. Then it turns up to another amplitude. Without the table, as long as I have my tick marks added, because we've thought out the jump, I know exactly what this function is going to do. Right now, I can't control Z, unfortunately, because I've already started drawing other stuff. You guys have the table in front of you, though. But does this look like cosine? How much of cosine do we have here? That's a weird question. There's a few ways that I can expect answers. So I saw 1. I have 1 cosine. That's what I need. I have 1 period of cosine. That's what is drawn here. Now, alternatively, if somebody had answered, and I'm just going to claim, they said, you gave me pi thirds. Where on earth did I get that answer from? You can't see it on my board, but you can see it on your work. If I said this is pi thirds of cosine, of this cosine function, where on earth is that number coming from? It's the same answer, just worded differently. 1 period is what we see on the board. 1 period was pi thirds. I see pi thirds of it. Now, most of the graphs that you guys get, and you'll see this on the notes, you'll see it, we graphed 1 period is all. Most of the time, I will ask you guys to graph several periods, so at least like 2. Could I graph another period of cosine here? Do I have to make a bunch of whole more table stuff? Why not? What do you mean it's repetitive? Like how would I draw the other periods if I don't do the graph? Just let it wave, right? Like let's just let it go. I see that it does something like this, and that's a half period, right? I've run out of space. The good news is if I say graph 2 periods, I don't say from the start of one until the completion of another. I just tell you 2 periods. Right now I have 1 period there. Right here is a full period of this. That's a half period. If I don't want to extend my graph because I'm already at the edge of my page, how do I get the other half period? Oh my goodness, it's right here. And I even have that tick mark made already, so I can just go right through it and look at that. I have 2 full periods of cosine. Now, I don't recall if your book does this. It drives me crazy when they don't. I would indicate that this thing keeps going. I know for a fact your calc books don't, and it really bugs me. Crazy difficult. Like, okay. Let's try one more. I want you guys to do one more. We're going to have much nicer values. Maybe. Do you want me to give you nicer values, or you just want to make one up together and see how it shakes out? Okay. That's the right answer, just for the record. All right. I want you guys to graph the following for me. And I lied. We should look at something real quick. Before we do that, I do want to check this. This function is taller than regular cosine. It's been moved and it's been condensed like this because the period went from being 2 pi to being pi thirds. So it's been shoved down. Now, my graph, and I stressed this earlier, you can't really tell from here because of the window that we've chosen. It's always going to happen. And I think the same thing happened with logs when we did it, where every log graph that we graphed, no matter what, looked the same because we always made our windows nice so we could see the graph very clearly. I just want to compare here. If I graph cosine of x, and this one was 3 cos of 6x minus 7. Is that true? Okay. The red one is the real graph that we just did. It does not look like our graph. Why? Yeah, I'm looking at the regular big window. This is the regular cosine, the black one. I can tell that that same path has been made way taller here, and it's been shoved down, right? I think I have a sign wrong on this, but I see the difference. Keep in mind that our graphs will always look nice, when in reality, if we compared it, they won't always look exactly the same because we get these changes. We're changing our window. Cool. All right. So I want you guys to do one more for me. And do I have a typo? Or do we have a mistake? Do we have the same graph? Yeah, that's where we started. No, we started. Where did we start? Here? 1.167. Where's their period start? Did I trust somebody's math and it wasn't quite? Nope, we're good. Cool. There's where we started. I should have trusted you. Sweet. I want you guys to graph one more. Now, here's the deal. I want to at least see your table started. If you want to make the whole big table, good. I love it. If you want to start your table and then not do any more middle work because you've verified and checked that that first point comes out to what it should, I'm okay with it. I'm going to leave you some freedom here. But in either case, I want you to graph B this time. And, ooh, should we get wild? Okay. Y equals negative, 1/2 the sine of pi x minus pi. Okay. I would encourage probably the first and second values of the table is what I think you should calculate out. But before you graph any of it, I want you to identify all those key things that we can use to build our graph. I'm going to give you guys a couple minutes to work. Head start on my end. Ladies, if you're watching this on the road, good luck tonight. And go ahead and pause the video when you're done. Resume it, and you'll hear me talk through it. So resuming the video in 3, 2, 1. Okay, digging in. Let's check all these first. Do you guys agree the period is 2? Which is weird, but that's nice. Is your jump 1/2? Is your start value at 1? And notice here, there's one little thing here that I want to clear up here. I'm going to be honest. I don't normally actually write the amplitude because maybe we don't truly need it. What is the amplitude of this? So I love that I hear that. And based on what we said yesterday, that's fair. I might not have given you the whole truth. The amplitude we said is half the distance from the top to the bottom, right? If you say how tall is your wave and you say half of it is -1/2, then you're claiming your wave has a total height from trough to crest of -1. We should probably say the absolute value. It has an amplitude of 1/2. It goes up or down 1/2 at a time. That's all it's telling us. What is a negative impact? And if you know it off the top of your head, and I think Dolan does, because I think I heard him comment, does anybody else remind me, what does a negative do if it moves in front of something? It reflects how? Over the x-axis. Now, there's a reason we're thinking about this. I know, and in my head, this is just me thinking right now, but here's what I'm going to use, because I would like to use the shortcut for our table, and I think you guys should. I know that this is what sine normally looks like. Starts at 0, goes up and down. If we reflected it over the x-axis, we wind up in what looks kind of like a double helix almost, but we get this, right? And the reason that I'm thinking about this is because if I'm going to try to use that shortcut, I just want to think about what it does. If I start here, I go up in amplitude or down? To get from here to here, how did I go? So I went down in amplitude, and then I go up, and then I go up, and then I go down. This is where I really care about finding that amplitude of 1/2. Now, if you don't want to think about this, and if you don't like it, it's not the end of the world, because you don't have to think about it this way. This is just how my brain makes sense of it. If you want to think about it a different way, or if you're not comfortable with that, where am I going to start? On my table, sorry. 1. Now, I'm going to take a little bit of, I'm going to show a little tiny bit of scratch work, but I'm going to do one thing in my head. Or not. -1/2, I lied. I'm just going to show it all. The sine of, this winds up being pi minus pi, which is -1/2, the sine of 0. Point to 0 for me. Here's 0. What's the sine value here? 0. What's -1/2 times 0? 0. Now, if I had not erased this, I can start using that down, up, up, whatever the situation is, but I can also reason it out. I know that this is the middle of my cosine, or my sine, because I know sine starts in the middle, and it goes like this. Okay, if I don't recognize that pattern, or if I don't want to have to think about it, let's just get one more point and see if the pattern shows up. Next one, I add 1/2 to it. 3/2 or 1.5, I'm okay with either. So let's just see what shakes out. -1/2 times the sine of, and help me out, what's pi times 3/2? So I heard a lot of weird ones. One more time. 3 pi halves. Did everybody see a combination or a variation of that? Okay, I heard a lot of different things. I just want to verify. Instead of writing minus pi, what's a better way to write it? 2 pi over 2, right? Okay, so what's 3 pi over 2 minus 2 pi over 2? Pi halves. Now, this is the indication that I'm right. And I always would encourage you guys to go this far at least, because I'm going to get a 0. I'm going to get a pi halves. What if I did it again? My next one would be pi and then 3 pi halves. I'm always getting these same nice values. What's point to pi halves? What's the sine of pi halves? 1, right? The y value up here is at 1. What's 1/2? Sorry, -1/2 times 1. -1/2. Now, it's at this point that I am comfortable enough. I know that my values are right because I've gotten 2 of them to show up correctly. And now is when I would really pivot back to that other idea. I know that sine normally, and I can draw it up here, and re-emphasizing, sine normally does this. But instead of this, we started here and we went down instead. Which, same thing, it has to go up now, right? And it's always going to move up or down by its, I heard Red say it, louder Red, amplitude. So let's see, I already went down 1. The next value is going to be 2. And instead of going down anymore, because I'm already at the bottom, I'm going to do what? I'm going to go up 1/2, which takes me where? Now the next one, I'm just going to write as 2.5, goes what direction? So now we're here. It goes up. And how much do I go upward? So now we're at 1/2. And then, like a good trig function, it winds back where it started. Boom. From these points, I can sketch this. Now, one of the things, just direction-wise, and I don't love it because they get really muddled and gross, but I bet if I look at this, When I read any of these random functions that say, oh yeah, graph this, they do something that I don't love. A lot of the time they say graph cosine x and this function on the same coordinate plane. I don't love the idea. I mean, I understand why we might do that to really see the changes that happen. But if we do that, we don't get always two really nice and easy to work with graphs. Do you want to graph the cosine and stuff as well, or do you just want to stick to having a bunch of graphs that look almost identical with the windows changing? Okay, so I'm okay with whichever one. On a homework problem, they say graph cosine and this other function. I'm okay if you graph the other function. I might ask some questions about what changed. Like I need you to tell me, did it compress or stretch, those sorts of things. But I don't need you to find a way to graph both of them nicely on the same plane. Okay, so here we are. I'm going to focus primarily on the positive side. Why did I show so much of the negative then? So I know I'm going to focus on positive x values. Why did I bother to show negative stuff here? So it's continuous. How many periods do you think I want to show? 2 is going to be pretty standard, just so you guys are aware. But I can plot these ones. What do you want me to jump by? 1? Okay, so here's 1. Just kidding. Here's 1, and here's 2, and here's 3 in case we need it. You tell me where's 1? At the very top? Okay. Which means this is 1/2. Okay, and I'm going to use that. So here's -1 then. And if I don't put any scale on these, what's the assumption that it is? 1. If no scale is written, I'm always going to assume it's 1. If you want it to be anything but 1, write that number at least once so I can see it. Okay, so let's check. 1, 0 here. And then if this is 1, then halfway across, I go down to here. Not all the way down to -1, almost. And then now my pattern just starts. Do I have what appears to be a period of sine? Now, it's upside down because it's really a period of negative sine, but it's the same general shape. It's just been reflected over the x-axis. How can I get a second period? Just let it go, right? We're just going to wave on by. There's a better joke waiting in there. So let's see, it goes up to there and then comes down. And I'm not really paying as much attention as I should, but that looks like a sine graph to me. Super hard. Easier or harder? And I want, like, honestly, and I'm sure I've asked you this before. Last year, were any of you guys guilty of just graphing on your calculator and just copying the graph onto a coordinate plane to make it look like you could graph it? Did you do that with trig stuff last year? Do you think it's easier to just do this or to graph it and just try to copy it and make sure everything is nice? Like, legitimately, you think this is easier than copying the graph from your calculator? That's the goal. Good. I want this to be easier. I don't want you to use your calculators. We don't need them. Okay. Should we do another one like this, or are we feeling okay with them? All right. I'm going to give you guys some homework. Cool. Tomorrow, we will be graphing neater functions. You know what? I'm going to write it here, though. Why would I do it there? And then I've been just spacing it over and over. While you guys are working, I'm going to be working on stuff too. But what's the most important thing right now for me? Is what I'm doing more important, or is what you guys are doing more important? What you're doing by a long shot, which means if I look busy, but you have a question, what should you do? Ask. Yeah, interrupt me. Please do. However, you guys get to start right now, homework 4.5, which is waiting lovingly on page 306. And I want you guys to do problems. Okay, I have more. Let's say it's 9 through 17 odd. And no. Okay, so on this one, we'll say it's 37. Not nod, just odd, so you know. 37, this is exactly what I was talking about. The directions say graph f of x equals sine x and graph this one. I don't need you to graph both of them. Just graph the bigger one. Only, and I'll even just say it specifically, x plus pi. And you'll see what I'm talking about. And I think I got one more problem for you. Maybe 2. 49, I got 2. 83 is way up there. Yep, love it. All right. I'm going to sneeze and do some... I wanted to get it out before that. Do you guys want to do a quick brain break before you start homework, or you just want to get in?